What is up, everyone? Welcome back. So we're going to continue working on data structures in Golang. So last time, what we did was we created a single linked list, which is the most basic type of linked list that you can create. It has each node has a value in the next pointer, and the linked list has a head, uh, essentially, and a length. Speaking of length, I forgot to increment the length and decrement it while we insert and delete nodes. So we can do that by length plus equals one or plus plus, and just do that everywhere. And in the case of deletion, we will be deleting. So we do a minus minus. Awesome. So uh, now I think what I want to do is create a separate file for singly linked lists. And yeah, so in this video, we're going to implement a doubly linked list, and I'm going to get to that in just a sec. But uh, what I want to do is create separate folders, like a separate module for linked lists, and in there we'll do a simply linked list dot go. Now this will have a package of linked lists, and I'm going to copy over everything that we have in here, including the main file including the main function, because what I'm going to do is instead of calling this main, I'm going to call this, uh, let's see, instead of calling this main, I'm just going to call this test simply linked list. And the reason I'm calling it test is because we're performing a bunch of operations here. It's not like a test, but it's just like a way to test out all of the everything that we've implemented so far in the single linked list. And I'm going to create a separate main function here, and I'll create a separate doubly linked list inside this. We're going to implement a doubly linked list. So it's similar to a single linked list, except that it's going to have a previous pointer in each node. And so in the linked list struct, we will have a tail as well. So we're keeping track of first the first node in the linked list as well as the last node. Uh, so we can we can copy over everything that we have here because we will be modifying this slightly. And I think I want to call this doubly linked list instead of a singly linked list. And yeah, since we already have a node here, we'll need to call this a doubly node. I'm just going to search and replace everything that we have in the singly module. I'm just going to add the suffix singly to all of the functions. So now that we've done that, I think everything looks good, except that I also want to change this to uh, new singly linked list. And I'm going to call this a singly node. And let's try calling this test singly linked list from our main. But before that, we'll need to modify the doubly linked as well. And we'll need to modify the print as well. So we just call it print doubly for now. So we will need to re-implement the print function anyway. So I'm just going to remove the print function. I'm just going to remove the print function and everything within the test function. So let's see what we have now. This is still not working, so let's see why it's not working. We're returning a linked list, that's the problem. So we need to return a doubly linked list. Okay, I think we've resolved everything and copied over uh, our simply linked list, like the foundation of it. We have it, in the W linked list now. So I'm just gonna like try to call this from our main now. And the way to do that would be first we'll need to import our linked lists module that we've just created. So we will do something like this, where our what's our thing called? I'm just gonna look at the Go mod, and we can copy this whole thing over instead of from Golang data structures, or we need to do something like this linked list. I think that's what we call. Okay, there's no underscore there. Okay, now we can import it. So I have the folder renamed incorrectly. I had a typo there. Now let's try to invoke our singly uh, test singly function. And this is why I've created separate functions for testing everything. Uh, yeah, so I'll need to rename this to have a capital name. Yeah, this should work. Now when we do go run, yeah, we see everything print out correctly. So we're inserting a bunch of times and then deleting it. Good. Now we can move on to our W linked list. I'm just going to quickly rename this function as well to have a capital start. So we can directly invoke it from here and then move on to implementing the W linked list. Uh, so we don't have to import the module and everything again. Now this is exactly what we had in the singly linked list, but now we're going to make this into a doubly linked list. So in, the first step would be to just have a previous pointer here. It'll point to uh, another. So this will be a reference to another node, but it will be the one that was before the current node. So let's say if this is our linked list at the moment, then the previous node of this middle list, this middle node would be the one that's before it. So this node, and the next would be that node, this node, and we'll have nil wherever we don't have a previous or a next node. Makes sense? So we'll also need to have a tail for the doubly. We'll need to have a tail for our doubly linked list. So the head is the first node in our linked list, and the tail would be the last node. And we can keep track of the length as well. So when we're creating a new doubly linked list, we first check if the user has passed a value. If it is nil, then we just create a nil, an empty linked list. So we'll also need to have the tail as nil. And if there is a value, then we are creating a head. And instead of calling this a head, I'll just call this new node. And this new node itself will be our tail as well as the head, because since there's only one node in our linked list, it'll be both the tail and the head of a node. So this is when we want to create a new linked list, which can either be empty or it can have a single node. Now, when we are inserting at the start of the doubly linked list, this is where everything gets interesting. So I'm gonna remove all of the contents of like all the body of our functions here, and we're going to re-implement all of these. So when we want to insert at the start of our doubly linked list, we will need to create a new node. So I'm just going to do that by creating a new doubly node, and I'll pass in the value. And now all that we need to do is whatever the head of the current doubly linked list is, we will set that as the new node dot next, and we will set the head as the new node. So this part is pretty similar to what we had in the singly linked list, but now we are setting the next pointer of the new node, but we also have a previous pointer. So we'll need to set. So before we reset the head, we will need to set the previous pointer of the head to the new node, and then we can set the current head to the new node and increment the length. And By default, the new node will have the previous pointer as nil. We haven't really done that, so let's just do that as well. So we'll set the previous to nil, and then let's say if this is the current state of our linked list, and we want to insert this. This is our new node. So what we're doing is we're setting, we're doing that. We are setting the next node, our next value there. So we've done that. We've set this, and this will automatically reset to, it was set to nil to begin with. So we don't need to set the previous value of the new node. All we need to do is set the next node, the next value for our new node and the previous value of our head, and set the head to the new node. And that should be enough. Now coming to inserting at the end of our linked list, we'll need to do something similar. Now that we have the tail for our doubly linked list, we don't really have to do the whole thing that we were doing earlier in our singly linked list where we were creating a pointer, we were looping through the whole linked list, and at the end we were setting the next. Instead, we already have a tail for our linked list, so all we need to do is create a new node, the value, and whatever the tail we have, we set the next of that tail to the new node, and we set the new node's previous to the tail, and then we just directly set the tail to the new node, and then we can increment the length, right? So most of these operations are pretty similar. Uh, all that we are doing is, so in this case, we are resetting the head to a new node, and in this case, we're just creating a new node and setting it as the new tail. Make sense? And deleting. So for deletion, we will do something quite similar to what we were doing in our singly, where we check if the head is nil, and if it is, then we don't do anything. If it's not nil, then we set the head to head.next. And now whatever the head is, we'll need to set the previous pointer to nil. So now uh, we have set the new head to whatever was next to the head, and we'll also need to check if new head is not nil again, because let's say if the head is the only item in our if it's the only item in our linked list, then we have a problem. Then we don't have anything to delete. So we check that first, and if there is a head, then we enter this part of the code, and where we set the head to head.next. And again, we check if now if the head is nil. If it is, then we don't enter this part. If it's not, if there is some value in the head still, then we set the previous of the current head to nil. And if the head is nil, so we'll need an else case here. So if the head is nil, then we'll also set the tail uh, to nil, because once we've deleted the head, if there's nothing left in the linked list, then we also want to set the tail to nil, and we decrement our length, and we'll do something. We'll do the same thing, but instead we'll be doing it with the tail. So if the tail is nil, then we don't enter that part, and we don't decrement the length either. So I'll need to change that a bit, and I'll need to change that here as well in our singly. So we only decrement if we are actually deleting. Yep. So that makes more sense. Uh, so if there is a tail, then we enter this portion and we set the tail to tail.previous. And if there is still a tail remaining, if the tail isn't nil yet, then we set the tail.next to nil, because If the tail is nil, then setting a next would kind of break our code. Since tail is nil, then it wouldn't have an attribute next because it's not a struct, it's a nil value. So we don't want to enter this part of the code. And if there is a tail, then we enter this part of the code and we set the next to nil. If there is no tail, then we need to set the head as well to nil and we decrement our length. And we can write our test function. So we'll create a linked list, which will be a new doubly linked list. We'll just start with nil. We will insert at the start of the doubly linked list. We will insert 1, 2, 3, 4. All right, we will need a print function as well. So let's just implement that real quick. So we will do print doubly and let's see. So we can have two different print functions. We can have a print forward and a print backward. So in print forward, we start from the head node all the way. So we start from the head node all the way to the tail. And in the print backward function, we start from the tail all the way to the head. So that's kind of the logic here. So there are two possible print statements that we can have. First, we'll have a pointer which will be the L dot head. And if L dot head is nil, if it's not nil, then we do something here. Else, we just print that the our linked list is empty. So why isn't that working? Do I already have format imported? No, I don't. Here. So we'll do that, and we will say that the linked list is empty. Cool. Uh, we'll need to have this on the next line. Forgot about that. So if there is a head, then we print the current value. If there is a head, then we just print the current value and then we enter the loop where so for pointer dot next we print that now that's the W linked list, we'll print that. And while it's not nil. So once we have that, we need to print, we'll do pointer equals pointer dot next and we'll print the pointer dot well. And this should print our linked list for us. So let's just use that for now. So ll.print doubly forward and we'll run our code. Okay, so the reason that we're seeing this error is that in our insert start method, we are directly referencing the current head.previous. And this is the issue that I was talking about earlier, where we don't have a head. Initially, we are initializing our linked list with a null head, and then we are trying to insert into our linked list. And in this function, we are directly referencing l.head.previous, while this itself is nil. It's not a structure. It's not a structure instance. So doing that would cause the program to panic. So we'll need to have a check here. If l.head equals nil, then we just set our head to the new node. And can we do something like this? L dot tail. This is what or doesn't. Uh, and we'll set the tail to that, and we increment outside of that whole condition. Cool. So we'll need to do this. We first check if the head is nil. If it is, then we just directly set the new node to the head and the tail. And if it isn't nil, which means that we have elements in our head, uh, now we can reference previous and next and so on for the head. And we need to do the same thing for when we when we are inserting at the end of our list. So let's see what we need to do. If the tail is nil, then we set the head and the tail. We can keep the same condition there, but still, uh, for better readability, uh, we check the tail. If it's nil, then we set the head and the tail to the new node. Else, we do the thing that we were doing previously. So now let's try to run it. Now we see that we are inserting our uh, our new node, and we should see that the W linked list is empty. Cool. And so now the problem is that we are seeing everything in one line. All right, all right, this makes sense. So we have inserted one node here, and it is pointing to nil as its previous and the next. This makes a lot more sense. This is a lot better to look at. And let's insert another at the start. So we'll do a 0, 1, 2, 3, and we will print it out. Okay, so the reason we see 83 here, I had to Google this. So numbers in Golang which start with a 0 are interpreted as like base 8 numbers or octal numbers. So instead of inserting that, we'll just insert this and try to run it again. And now everything works really nice. So, and now we'll try to insert at the end of the link list. So we just insert something like this. And now we know that we are inserting at the start and at the end. Really cool. So now let's test the deletion. And to do that, we will delete start doubly and then try to print it out. Let's see. Okay, so we did delete 7890. Now let's try to delete at the end of the doubly linked list. So delete end, print it out, but that will. Okay, did. Awesome. So we have a function in doubly linked list here, and it's really cool because now we can traverse our linked list both forwards and backwards because we have a previous pointer. We can start all the way from the end of our linked list as we just. Oh yeah, we need to. We wanted to also implement this print doubly backwards. So this should be pretty simple as well. All we need to do is start from the tail uh, and move towards our head. So we'll initialize our pointer uh, as the tail, and if the tail is nil, if the tail is not nil, then we do whatever we are doing. Uh, so we print out the value, and while the previous isn't nil, we just move towards our previous. If we're printing backwards, then we want it to print correctly still. Like we want the arrows to be pointed in the right way. Uh, we can add like a note here which is backwards, or we can like write tail here and we can write head here. And similarly, we can write head here and tail here. So this makes a lot more sense. Now, if we print it out, we can see that where the tail is and where the head is. And while we have the most elements in our linked list, we can try to print backwards as well and see what we see. So yeah, we are printing backwards. We are starting from our tail and going all the way towards our head. Uh, yeah, this is our head, which we had previously. Yep. So This is really cool. Like now we can traverse both forwards and backwards, and that's the benefit of having a doubly linked list and not a singly linked list. Cool. So in the next video, we're going to move forward with a few more, a little more complex. We're going to get a little more complex. We're going to implement different data structures. So stay tuned. Thanks for watching.